Hello. It's a big, big, big place. Big screen, small man. This is going to be my last session in Dev Day. I had a workshop yesterday and an IndexedDB session in the morning. And this session is all about graphics. Yay! Graphics! No, it won't be all about graphics, but it will partly be about graphics. But there is a big but. I'm not a graphic designer. This is me trying to do something, trying to paint something. This is how I draw toilets. I wish. This is more appropriate for me to draw something, okay? And somebody gave me the opportunity to speak with you about graphics. Uh-oh. Oh, okay, so let's get serious, okay? I know a little bit about graphics, and we don't need to paint anything, because we are going to talk about graphics in the browser. About me, I'm Gil Fink. I'm Sparks' CEO. I'm also a consultant. I'm Microsoft MVP in the last 7 years. I wrote some Microsoft official courses, mainly HTML5 programming and programming with HTML5 and Windows 8. Who uses Windows 8? Nobody. And I wrote a book called Pro Single Page Application Development with a partner which wrote everything about the server side, and I wrote all the chapters about the front end. I also organize Angular App Conference. I'm a co-organizer of that conference. It will be in the 17th of November. You can come to Israel, where I live, and be a part of the Angular community. If you're a part of Angular community, I think that you should come. We'll welcome you. And I'll also have a meetup that I co-organized called GDG, Google Developer Group, in my hometown, Rishon. What we are going to do here in the next 45 minutes is as follows. We will go and talk about a little bit about SVG in a nutshell. I probably think that most of you know SVG. Raise your hand if you used SVG somewhere in your app, okay? And then we will drill down now to use SVG with Angular 1 and 2 that was released today, okay? Yeah. And then I'll delve into a use case where I used both Angular 1 and SVG to create a biology modeling for some company. So SVG in a nutshell. SVG is a graphical model. It's a scalable vector graphics. This is what SVG is all about. The graphics scales good in every kind of screen, and you get 2D vector graphics in HTML. In a whole, it's just an element called SVG that you put other elements inside of it. It is DOM. It's part of the document object model. So you can use JavaScript to manipulate it. You can use CSS, a specific CSS to manipulate it. You can talk with it with events. You can do clipping, linking, whatever you like in order to create the graphics. Here's a small example of SVG. We have a SVG surface. Inside of that SVG surface, we have two rectangles. The first one is red, the second one is blue, and SVG will layer the last elements on top of the first elements. So what we can do with SVG? So I like to play games. You can see my Alienware here. And here is a game written in SVG that it is called Blobular, and you just divide some blobs into small blobs, and then you take it here, and you swallow other blobs. Let's try to swallow this thing. My mouse isn't helping me, okay? I swallowed it, I divided it, and everything else. This is cool. This is a game written in SVG. Another game that you can find online that is written in SVG, and there are more games that you can play. I like playing games. Is this puzzle. So let's try to make this puzzle. Okay, I won't waste your time playing that puzzle, but it's addictive. Okay, you get it. You get the idea. Okay, so we have SVG, and we can create graphics with it. But I said that we're going to talk about SVG and Angular. So how can we use SVG in Angular? How can we combine SVG in Angular? So it's not hard. You already know how to do that, because SVG is DOM elements. So if it's part of the DOM, I can create elements of SVG using Angular directives. There are some caveats before you do that. Okay, so let's talk about the caveats. First of all, if you're creating an Angular directive, you have to say that the directive is going to generate SVG. You will have to put template namespace in the DDO, the directive definition object, and point it to SVG. If you won't do that, you will get an HTML element and not an SVG element. Okay? The second caveat is, once you create things inside of the SVG, SVG doesn't know what is data binding in Angular. So if you use curly brackets, it will fail. So if you ever used SVG with Angular, you need to put a prefix called ng-attr- in front of every attribute that you're using, and then Angular will understand that it's going to be data binding, and the expression will be evaluated, and it will work. Cool. So let's see a demo. So here is a template of a rectangle, rect template. And I have ng-attr-x for the x-axis, and ng-attr-y for the y-axis, and so on, height and width. And I have a corresponding rect directive. Here is the directive code. And you can see here that first I'm grabbing the template URL. The relevant issue here is the template namespace equals to SVG. I restrict it to be an element. You should restrict all the directives that you create for SVG to elements. Don't use attributes. In Angular 2, it's the opposite. And I'm putting here the scope, and I'm binding these variables into the scope of this directive. That's all. And here's the demo controller. I have a controller that the directive that the demo will use. And you can see here that I set some attributes on it and nothing more. The last place here is a directive for the demo itself, which is just an element bounded to the controller, the demo controller, and I use controller as syntax in order to put things. The demo template is easy. We have the SVG, a rectangle, ng-rect, this is my directive, and some inputs that will change the rectangle sizes. So this is easy. Let's run it in the browser. And we get this thing here, and we can manipulate the rectangle here and play with it up until we drop dead. Okay, so this is a small demo how to use SVG and Angular 1. We have 2 cavets, remember those, and you're fine. How can you do it with Angular 2? So Angular 2 has its own cavets. The first cavet is you need to put SVG semicolons prefix before you use some SVG element. Okay, so you can see the first example in the slide. I have a circle, I put SVG semicolon and circle. If you want to use data binding in Angular 2, you have to use the attr dot notation as prefix for every attribute. And that's cool. That's all. But I have to say another caveat which is very, 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 very important. SVG doesn't know directives or components from Angular. In Angular 1, it was easy. We put a directive, we say that it's an element, and that's all. In Angular 2, you will use SVG attributes in order to generate something in SVG. And what I mean is, I will create the component as an attribute. I will set it to an attribute and not to an element. If you will set it to an element, you probably will get an error somewhere in your application, from experience. So here is an example of using SVG with Angular 2. I have the same rectangle here. This is the syntax of the component. You see the selector here that will search for ng2rect attribute and not some other component. I'm using the SVG semicolon in order to decorate the element and say to Angular, hey, Angular, this is an SVG element. I'm using the attr dot notation in order to bind something, and the something here is just the variables that I get inside of my component using some inputs. Okay, so I have an input for x-axis, y-axis, rect height, and width. Here's the demo component. It will use directives. This demo was written with previous version of RC. It won't work in RC5 and next versions because this directive was deprecated. But you can run it and remove this directive and bootstrap the application with ng model from RC5, and everything will work. Okay, so bear with me. So we have a template, and we have these things that we bind to our demo, and we have the labels that are, the inputs that are decorated with ng model to help me manipulate everything, and I can run this thing here, and we get the same demo, but in Angular 2. Okay, that's all. So we know how to use Angular 1 with SVG and Angular 2 with SVG. What else? Use case. I told you that we are going to talk about biology modeling powered by Angular. And I think it's like half a year ago, I left a company that I was consulting for, and I helped them build a Genome Viewer. So I'm going to talk about the process of how we build that Genome Viewer using Angular and SVG. And disclaimer, I don't know biology at all, okay? So don't expect me, don't ask me questions or biology questions, because I will say something like, go to your doctor or something else, okay? But I needed to learn a few things about biology in order to create that Genome Viewer, and I'll have to do some biology 101 for you in order to understand what you are going to see later on in this session. So biology 101, what is plasmids? A plasmid is just a representation of molecules as a circle with annotations. Think about this circle as a germ, okay? A big germ that has a lot of features in it. And we annotate those features using some things like the circles here, which are called annotations. This is one thing that you need to know about before we drill down into the demo itself. The second thing is, what is a sequence? So a sequence is just a permutation of ATGC. We are all written in ATGC characters. Okay, so think about it as the code that represents something. Okay, this is the sequence. It's again the representation of a molecule, but in characters only. So what were the customer's needs? First, create me a sequence and a plasmid view for some genetic or biology files. Okay. So load the files, parse them, and create me a viewer. synchronize the Plasmid and the sequence view. If something changes in the Plasmid, update the sequence, and vice versa. They wanted fast scrolling, because you need to scroll. You can't put the entire sequence inside of your web page, so you need to scroll. They wanted to be able to select some parts in the sequence and in the Plasmid. And they wanted a lot of annotation layers that in the runtime you can create or dispose those layers instantly. Uh-oh. A lot of demands, a lot of requirements. So if you get those requirements, what's the first thing that you will do? I'm a lazy developer. The first thing that I'm going to do is there a JavaScript library, because they want a web page, that gives me Plasmid or sequence representation, hopefully with Angular, because they want Angular in their application. Okay, I will try to find it. Maybe in Byojs, you can write or you can picture that link. Byojs is a repository that includes a lot of libraries out there to help you to do some biology stuff. So I went to Byojs and I searched deeply, and I found Angular Plasmid. Somebody did half of my work. Thank you. So what is Angular Plasmid? It's a DNA Plasmid representation or visualization that uses Angular. So you write some fancy elements and you're fine. But my requirements were to load files dynamically, parse them, and generate them. So how can you do that? You use the compile service in Angular, you create the elements dynamically, and then compile them and add them to your web page. Also, we didn't have any option to selection on the Plasmid, so I had to create my own. I used linear algebra and things that you probably learned in university in order to create that. But this is another discussion, how to calculate on the screen some things. Okay, so let's see how we use the Angular Plasmid with SVG. So here's some. This demo will be online later on, okay, so I promise. So bear with me. The first thing here is we have an Angular application that does something. What this application is doing is as follows. I'm going to choose a file. Let's go to the lecture. Let's load some file. Oops. Example file. Okay, I loaded the file and then I just generated from the file itself. If I want to look at the file, it is in FASTA format. FASTA is one of the known formats for biologists. Okay, this is the FASTA format. You have a caret and then the name of the Plasmid or the name of the sequence and then the sequence itself. So it's easy to parse it. There is another format which is much more sophisticated called GenBank, and we have GenBank parser in the Genome Viewer that I will show you later on. So we have the FASTA file. Here is the FASTA parser service. It's written in JavaScript, and what we need to do is just split load the file, get the text, load and split it by lines, and then take the first line, retrieve the name, and retrieve the sequence from the second line. That's all. That's easy. We have a file reader here that uses HTML5 file reader in order to read the file from the input file type. And this is a directive that will do that for us. And it will bind something to the scope here, the FASTA content. This is the file reader itself. It reads the file as text and nothing more. And the main issue here is this ng Plasmid directive. This directive, in the link function of the directive, will wait for us to, will wait that somebody will give us the representation or the file which is in memory, okay? And it will draw it. It will create the Plasmid for us from the data given and compile that and bind that to the scope. These two lines will create the circle that you saw earlier. In order to create the Plasmid, you can see that we can use the document.createElement and create the elements according to the Angular Plasmid representation or documentation. Okay, so this is very, very, very easy. If you will download the demo itself, you will be able to understand what is going on. And there is an article I wrote in .NET Curie that shows you how to implement this as well. Okay. So we saw Angular, Plasmid, and the compile, and we have a hint of how to create our visual genome visualizer. But here is the big but: there was no DNA sequence library. I had to create it by myself. So at first, I thought about it and I said, let's go the naive way. Let's let Angular generate everything using an ng repeat and put that repeater in the repeated items in the SVG and I'll be fine. Really? Then I will add the annotation layers and everything else. So there is a problem here. Sequences can be with unlimited amount of characters. What's the problem? With great data source comes great performance tuning, or great responsibility, okay? So yes, it can't work because if you have 100 characters in a DNA sequence, it will work, but if you have 10,000 characters, it won't work and your application would be very sluggish and slow. But I need fast scrolling in my application. So what can I do, or what can we do better? Is infinite scroll, for example, can be the answer to my prayers? So if I'm asking it, probably it's not. You know why? Because infinite scroll adds to the DOM more components, and more components once you scroll down. And if you add more elements to the DOM will be bigger and bigger and bigger up until everything crashes and nothing works. So is there another way to create that fast scrolling? Yes, there it is. Virtual scrolling. The idea of virtual scrolling is that I'm only creating a portion of my viewport, a few elements on top of it, a few elements below it, and that's all. And then when somebody is scrolling and getting to a threshold that I calculate, I start to move elements from up to down. I'm killing the elements from the above, and then I'm creating a new elements below, or if I'm scrolling up, the opposite. There is a good reading that you can look at in Google. They have a very good document to explain how and when to use virtual scrolling. And there is a blog post in 2 parts about Angular and virtual scrolling that can help you to create your own implementation. Please don't do that. There are libraries that gives you virtual scrolling. But if you want to do that, go ahead. I won't stop you. And last but not least, let's get to know the Genome Viewer. So first of all, a little bit about the architecture. We have a directive to create our header. In the header, you can manipulate 2 things. You can rotate the Plasmid, and you can change the font size of the sequence. We have the Angular Plasmid inside of a directive that will be generated according to the file that we are going to load. We will have a second directive to create the sequence, and we have a footer with some options that you can use For example, you can see down below on your right side annotation layer button that enables you to remove or add annotation layers to the sequence and to the Plasmid itself. Every row in this implementation is a directive, of course, and we create everything from scratch, not with Angular sequence or something like that, okay? Do you want to see that live? Yes, at last, something interesting. No. So here is the viewer. It will take a few minutes, 3 seconds. Here's the viewer, okay? And as I said, we have annotation layers here, so I can remove some parts very, very quickly in the representation. You can see that things are omitted from the Plasmid and from the sequence. I said that we have fast scrolling, so let's see fast scrolling. Okay. We can rotate the Plasmid. Yeah. We can select things on the Plasmid itself. Okay, and you see that we jump from one place to another. We can do the same selection on the sequence, and you can see that in the Plasmid it's updated instantly. Then we can do things like this, and we can get more information about anything inside of the sequence or inside of the Plasmid. We have annotation layer summary that helps us to jump from one place to another place or to a specific location. Let's jump to this location. And we can change the font size to something smaller, or if we have glasses like I do, something bigger. And we get a lot of details that biologists will probably understand, but I don't understand. For example, GC or TM or whatever. Okay? Cool? So let's summarize. SVG, Scalable Vector Graphics, give you the opportunity to create graphics in the browser. It is one model. I didn't mention that you have a pixel graphic model, which is used by a canvas element. And SVG can cooperate and combine with Angular 1 or 2, except for the Cavets that you need to tweak it a little bit in order to make it work. You can create very sophisticated modeling using SVG and anything else. It can be Angular, it can be React, it can be Aurelia, Embel, whatever, what you like, as long as you do that. And this is what I have to say to you. Please, don't be bounded to graphs for SVG or any other graphical model. Think about other ways to represent your data and just implement it. Thank you. If you have any questions, that's the time.
Have you ever considered trying the D3 library for?
Okay. So the question was if we consider D3 to create the sequence representation. So the answer is, of course. And it didn't work well, so we ditched it, and we created our own implementation. Any other question? Yes, I will hope that I will hear you from far away. Is there an ability to combine SVG and React.js, or is there ability to combine React and Angular? Because these are two different questions. Okay, so the first one, the React with SVG, of course. Okay, React knows how to render SVG, and I did that in project 4 months ago. Okay, so of course. Combining Angular 1 and the React, you can do that, but you will have two different view engines coordinating. And while in some places, for example, the sequence, we we should have considered to create it with React because they are promising that it will be fast if we are using React. I think that since I left the company that I created, the viewer, they are migrating all the sequence solution into React. So currently, in my implementation, it's in Angular, but they are moving to React. So probably you will have a same application with Angular and one part which is React. Okay? Any other question?
This was a demo, yes? Or something small?
What?
Yes.
What you saw, the Genome Viewer, it's online, and there are companies, biology companies that use it. And it's part of a major solution that the company, I don't want to mention the name because I'm not doing any PR, it's part of their products. They have few products, and this is one product that they have.
I saw something similar, which is called Circos. This is a Genome Viewer. And
They are competing with the company that I talked about. Okay? Any other question? Okay, again, thank you for joining me, and I'll see you here. I'll be here if you have any other questions up until tomorrow. I hope that you enjoyed the session. Thank you.